Hi everyone. Okay, so on the first page of Chapter 13 Study Guide, the first page is basically the quiz. The bottom question of that first page is a problem that you're going to see, a similar problem on the quiz. And it states, Bob Company is considering the purchase of a machine that would cost $380,000. It'll last for 5 years. At the end of 5 years, the machine would have a salvage value of $60,000. By reducing labor and other operating costs, the machine would provide annual cost savings of $80,000. The company requires a minimum pre-tax return of 10% on all investment projects. What's the net present value of the proposed project? Okay, you're going to have to look at this table yourself. And there are tables at the end of the chapter. So on the ebook, look at the end of the chapter. And if you look, what they're talking about an annual cost savings of $80,000. You're going to get that year after year after year. That's an annuity, something that you receive year after year after year, period after period after period. That's an annuity. So you're going to look at the present value of an annuity. And for our example, you would see that for 5 years at 10%, the discount rate would be 3.791. So you would multiply the 80,000 times 3.791 to get the 303,280. The other amount you're going to get, that salvage value, you're getting one time. If you're getting something only one time, you're going to look at the present value of a dollar table. So if you looked at the present value of a dollar table, you would see 5 years at a 10% rate is 0.621. So if you multiply that by 60,000, you would get 37,260. The initial investment today, the 380,000, that's not discounted. That's in today's dollars. So that would be 380. So when you add and subtract these various numbers, you end up, in our example, with 39,460. It's a negative number. That's the net present value. Just so you know, you have to be careful with those tables. What the tables are talking about is you're given some future amount, you want to know what it's worth in today's dollars. If it's one sum of money, you look at the present value of a dollar. If it's the same sum of money over and over and over again, you look at the present value of an annuity. Okay, moving on to the next page. This is an example of problem 1. Management of Bob's considering the purchase of a $40,000 machine that would reduce operating costs in the warehouse by $10,000 a year. At the end of the machine's 5-year useful life, it will have no scrap value. The company's required rate of return is 10%, and we're going to ignore income taxes, and we want to determine the net present value of the investment in the machine. So for this one, our annual cost savings, and we're going to receive that year after year after year, so we're going to look at the present value of an annuity. The savings is $10,000. Our discount rate is 10%, so if you looked at the table, it would be 3.791. If you multiply that by 10,000, you would get 37,910. Initial investment in today's dollars, we're not discounting it, it's already in today's dollars, is 40,000. So if you add the two together, you get a negative 2,090. So that's its net present value. When you're looking at these tables, you are just looking at the horizontal axis and the vertical axis, and you're looking at where the two meet to get these discount factors. Okay, problem number 1 is also asking, what's the difference between the total undiscounted cash flows and the cash flows over the entire life of the machine? Well, if we didn't discount this, we'd get $10,000 a year for 5 years, so we'd get $50,000. Subtract the $40,000 of the amount we're spending today, and that would give us a $10,000 positive number. Next one, number 2, Bob's investigating the purchase of automated equipment. He would save $1.4 million. Oh, excuse me, I'm sorry. He would save $200,000 each year in direct labor and inventory. Equipment costs $1.4 million. Expected to last 10 years. There's no salvage value. Company's required rate of return is 12% on all equipment purchases. Equipment would provide intangible benefits such as greater flexibility and higher quality output that are difficult to estimate and yet are quite significant. What dollar value per year would the intangible benefits have to have in order to make the equipment an acceptable investment? So we would change this, of course. Now we're looking at 12% rather than 10%. So if you look at 12%, the cost of the equipment now, of course, is 1.4 million. It's already stated in the present value, so our amount is 1.4 million. We're going to have a cost savings of 10 years of 200,000 a year. If we look at a 12% discount factor, again, this is over and over and over again, so we would look at an annuity, present value of an annuity. The factor would be 5.65. If we multiply that by 200,000, we get 1.130 million. If we subtract that from 1.4 million, we end up with $270,000. And I'm sorry, I don't know why I put the parenthesis there. The 1.4 is the amount we're spending today, so that's our negative figure. There's one other step in this problem. We want to know what the dollar value has to be on the intangible benefits. So the way we're going to do that, we're going to look at the net present value. So our required increase in the net present value is the 270,000, and we will divide that by our 10-year factor, which we already determined. Our 10-year factor is the 5.65. So if we divide 270,000 by 5.65, I rounded this number, it's not exact, but it would be $47,788 rounded.